Hi there, welcome back to my channel. Hope you are doing well. In today's video, we will be solving this medium lead code problem 167 to sum 2, where input array is already sorted. I already have solved 2 sum 1 problem. If you want to check that solution, I will provide the link in the description box. Let's understand the problem now. We are given one indexed array of integers whose name is numbers, which is already sorted in ascending order. Now we have to find out 2 elements from that array which sums up to a specific target number. We need to focus here on the fact that this index is 1 indexed. So the first index will start from 1 instead of 0. We have to return the indices of those two numbers which sums up to the target, and we can return that in the form of a list. They are saying that these tests are generated in such a manner that there will be exactly one solution. So we need not to worry if solution is there or not, or if many solutions are there. There will be only exactly one solution. We have to return that, and we can't use the same element twice. There is one follow-up also, that solution must use only constant extra space. Let us try to understand the problem with the help of examples. Here numbers is 2, 7, 11, 15 and target is 9. So in this case 2 plus 7 is 9. So 2 is at index 1 because this is one indexed array, and 7 is at index 2. Hence we will return 1, 2. In example 2, the numbers are 2, 3, 4. Here target is 6. In this case 2 and 4 sums up to 6. In this case we will return these indices. 2 is at index 1 and 4 is at index 3. So we will return 1, 3 here. In example 3, we have a negative number also, -1 and 0, and the target is -1. So both these two numbers will sum up to -1. Hence we will return 1, 2 here. We have constraints defined over the length of the array, that is numbers dot length, and then the value of its elements. It can be from -1000 to +1000. We can have the negative numbers in our array. Then our numbers is sorted in non-decreasing order, that is in ascending order. Then we have a target value constraint that it will be again between -1000 to +1000, and as discussed earlier there will be exactly one solution. Let's discuss the approach now to solve this problem. I have taken the example 1, but in target I have updated the value to 26 because earlier with 9 we were able to find the solution in first two elements itself. So to make it a bit complicated, I have updated the target value to 26 to understand the approach better. Now the brute force approach to solve this problem would be, we will start with one element 2 and see if 2 is able to make up 26 by adding itself to any other element of the array. With 2, we will check 2 plus 7. No, it's not 26. 2 plus 11, 2 plus 15. Now, since first element is not able to do that, we will shift to the next element. Now with 7, we will see if 7 plus 11 is 26. No. 7 plus 15 is 26. No, it's not the case. Now we have to move to the third element, which is 11. From 11, we are left only with one element, 15, and 11 plus 15 is 26. So we can return these indices 1, 2, 3, 4. So answer will be 3, 4. But when we are solving by this approach, we have to run through two loops which will sum up to the time complexity of order of n square. To optimize this further, we can make the use of the fact that this array is in sorted form. The elements are in increasing order. In this array, the first element is the smallest one and the last element is the largest element in this particular array. So if we sum up the first and the last element, we will get 17. 15 plus 2 is 17. Now 17 is less than 26. So to make it to 26, we need to add some more value to the element. To do that, what we can do, we can, instead of 2, we can add 7 to 15. We can try that. So if we add 7 to 15, now it will be 22. 22 again is less than 26. So we still need to add more value to our element. Again, we will try to add a bigger element. We will add 11 to 15 now. 11 and 15 is 26. We found our target match here. Hence, we can return these two indices as a result. So these two indices would be 1, 2, 3, 4. So these are 3, 4. This will be the return value for this example. In this example, we kept on increasing the value for left side of the element. But there could be some other example where we have to decrease the value also. Let's see some variation of this example itself. If the target was 18, we will start from first and last element. First is 2, last is 15. So 15 plus 2 is 17. 17 is less than 18. So we need to add some more value to the element. In that case, we will move this left pointer to 7. Now we have the two elements 7 and 15. 7 and 15 is 22, which is greater than 18. So we are crossing beyond our target value. Now we need to decrease the value of our element. In that case, we will move this sys pointer to here. Now the elements that we are working on are these 7 and 11. And 7 plus 11 is 18, which is equal to our target value. Hence, we have found our elements, which are 2 and 3. I hope you have understood the idea. Basically, what we are trying to do, we are keeping a track of left and right pointer. Left pointer is starting from here and right pointer is starting from here. So whenever the value of current two elements is greater than target, if it is greater than target, it means we need to decrease the sum. So we will move the right pointer towards this. But if the sum is less than the target, we will move the left pointer, and eventually we will be able to find the solution. As said in the problem, there will always be a solution to this problem. Let's try to write the code for this. We will initialize two pointers, left to 0 and right to length of numbers -1. We will run one while loop while left is less than right. You can use while true also here instead of left is less than right, because we are always going to have some return value from here. As said in the problem, we will always have a solution, so we will always return some value. But to be on safer side, I am using this while left is less than right. Now if sum of the current elements is equal to target, in that case we will return the indices in the form of a list, left comma right. But as said in the problem, this is a one index array, so we have to add 1 to these indices, else if sum is greater than the target. In that case, we will move right pointer towards the left. In the other case, we will move the left pointer to the right. As per LeetCode, we will always be able to return some value from here because there exists one such pair. But just to follow the standard coding practices and to be on safer side, I will return either I can return an empty list here or just an empty return statement will also suffice. Let's try to run this solution. Sample test cases are running fine. Let's submit this. The solution is accepted. We can now talk about its time and space complexity. Here we are defining two variables, left and right, which will take space complexity of order of 1. So we can say the space complexity is order of 1. No other variable is defined, hence it will be a constant space complexity. And then we are executing one loop. This loop will be executed maximum n number of time, where n is length of the numbers array. So its time complexity would be order of n. All these operations will take order of 1 time complexity, hence I am not considering that, because even if I consider that, it will be something like this and it will result in order of n only. So in totality, if we see, we have a constant space complexity and the time complexity is order of n. This is all about this problem. If you have a better solution to this problem, or if there are any suggestions to enhance this solution, please let me know in the comment section and visit my channel for more such videos. Thank you so much. See you soon. Bye.